Good day, my fellow grade 11 geographers, and welcome to yet another episode of the grade 11 Geography Caps series. And once again, thank you for tuning in, for being part of this family. Please don't forget to like, subscribe, comment, share so that we can grow this channel even further and so that we can get motivated to create many more episodes of the grade 11 Geography Caps series. Now, as you can see, guys, in this video, we will be covering or discussing the role of winds and ocean currents in the transfer of energy. And going to our CAPS document, we can clearly see that this is the third concept under the subtopic, the Earth's energy balance. Right, so that's what we're going to be covering today, the transfer of energy and energy balance. Remember, guys, we said that in the last video where we covered both of these concepts, we said that these cause energy imbalance. We said that we see an energy imbalance and we discussed why there is an energy imbalance. Okay, so if you haven't watched that video, please do. It's important that you do so. I would advise you to do so. So we said that we have an energy imbalance that we see, and we discussed all the reasons why we have an energy imbalance. And so in today's video, we will be discussing how this energy balance is then restored or is then corrected. So again, guys, in the last video, we said that the unequal heating of the earth causes an energy imbalance. Okay, so we talked about the sphericity of the earth, okay, it being nearly spherical and hence not equally heated. We said that the equator receives most of the energy from the sun and that the poles receive less energy. Okay, so in other words, there is a positive heat balance that we see in the equator, because we said that in the equator a lot of insolation is gained more than lost. Okay, you have more heat that is gained than lost. Remember, you have processes such as reflection, absorption, scattering, so on and so on. And so you do lose some energy on the way in the atmosphere, right? But because the equator receives direct sun rays and that these sun's rays are concentrated over a small area, this means that there's a positive heat balance here. There's a lot of energy that is received here because the equator receives most of the insolation throughout the year. I even highlighted the equator with the color red to emphasize that there's a lot of energy that is gained there, right? So we have a positive heat balance in the equator, and then we have a negative heat balance in the poles. Okay, so the poles, we discussed that they receive oblique sun rays and that the sun's rays are concentrated over or are spread actually over a large area. And so this makes the insolation they receive very small, okay, comparatively small. And the fact that they have snow or ice, which reflects a lot of the sun's rays, this means that a lot of energy is lost than gained. Okay, there's more energy that is lost here than gained. So there's a negative heat balance here. The little amount of energy that is received is lost. And so that's why it is very cold in the poles, right? And so now this is an energy imbalance because you have more energy in the equator and you have less energy in the poles, okay? And so that's what we mean by energy imbalance. Again, guys, if you really want an in-depth explanation, please check out the previous video. Now, this becomes a problem, guys, because now there's no balance. Okay, so this energy has to be distributed everywhere so that there is a balance in terms of the energy, right? Before I get on to the second point there, I really want to mention this, and this is how you should really look at how air works, or the relationship between temperature, pressure, and the resulting weather. That is very important to note here in geography as a whole. So here's a scenario, guys. I have a taxi on the left hand side, so let's call this A, and B on the right. So A, we have a taxi, so this is a taxi, right? And then B on the right, that is leaves. Okay, those are your leaves. So between A and B, which one would you say applies a lot of pressure on the ground, right? Which one between A, the taxi, or B, the leaves, apply a lot of pressure on the ground? You would say it's A, right? Definitely you would say it's A. And if I would ask your reason, well, you would say it's because the taxi is heavy and so it applies a lot of pressure on the ground. Now, this is quite an important thing to note here, okay? Because we talk about the atmospheric pressure almost all of the time in climate and weather. And so it applies a lot of pressure on the ground. Okay, so we say that it creates an area of high pressure. Okay, because it is heavy. Okay, so because it is heavy, it applies a lot of force on the ground. That is a lot of pressure. That's how it works. Okay, so assuming that these two objects, A and B, occupy the same surface area, A will definitely have a higher force, right? So it will apply a higher force on the ground and hence a higher pressure, right? And so because B is light or is less dense, so we can use light or less dense for the leaves, and we can use heavy or dense or very dense. Okay, because this is heavy, it applies high pressure on the ground. It applies a lot of pressure on the ground, right? And so it creates an area of high pressure on the ground. And because B is light and less dense, it applies less pressure on the ground. Okay, less pressure, or we can say low pressure. Less pressure and low pressure is the same thing. Okay, and so we say that because B is less dense, it applies less pressure or low pressure on the ground. So it creates an area of low pressure on the ground. Okay, now let's come here just a bit. Don't mind the heading there. So we're saying that warm air or light or less dense tends to rise. So that's the characteristics of warm air. Okay, so if you have warm air, okay, let's say these are the particles of warm air, they tend, because they are light or less dense, they tend to rise up. They are less dense, guys, than the surrounding air particles. It's like let's say we have a baguette, right? Let's say it's I don't know, 5 liter baguette, right? So it's a 5 liter baguette. And now let's say a can. Okay, let's say I take a can of Coca-Cola for an example, right? So let's say it's an empty can of Coca-Cola. I take this can and I place it in here. Okay, let's say this is full of water. Let's say there's water over there. It's water, it's full of water, right? And I take this can, right? And I push it down. Okay, let's say I push it such that it reaches the surface or the bottom of the bucket, and then I let it go. Okay, what happens to this can? So this can is going to rise up. So this can of Coca-Cola is going to rise up. Why does it rise up? Well, it's because it is less dense. Okay, it is light than the surrounding water that it is in, right? So that's exactly what happens here, guys. You have a warm air MS. This warm air, because it is light, because it is less dense, it's going to rise, it's going to expand, okay, and rise up. And so how much force is it applying on the ground, right? We're saying it is rising up, right? It is rising up. How much force is it putting on the ground? Okay, it's little force, very little force. Okay, it's not stepping on the ground, it is rising up, and it is light anyway, right? And so we say that an area of low pressure is created, or we say that warm air is associated with low pressure. Okay, so warm air rises up, expands, and therefore creates an area of low pressure there. Okay, that is important to note. Low pressure, how much force is it applying? It is applying low force. It is applying a very little amount of force, and therefore a very little amount of pressure. Okay, pressure and force, they are directly proportional if you keep the surface area constant. And then what about cold air? Cold air is naturally heavy, right? It is heavy, and so it tends to sink down. Tends to sink down. It tends to stay on the ground, like put a lot of pressure on the ground. Okay, you can imagine cold air as this huge guy that is sitting on top of Earth. So, or a giant that is sitting on top of Earth. So, that is applying a lot of pressure on the ground, a lot of pressure on the ground because it's a lot of force. It is heavy, and so it tends to sink down. It cannot rise up. It does not have sufficient energy to do so. So, it tends to sink down and and pushes down on the surface, creating an area of high pressure. So cold air is associated with high pressure because it applies a big, comparatively huge force on the surface. So cold air associated with high pressure, warm air associated with low atmospheric pressure. That is important. Okay, how much pressure is it putting on the ground? On the ground. Okay, and then we have this famous principle here in geography, in climatology, which says air will always move from high pressure to a low pressure, or from an area of high pressure to an area of low pressure. We'll talk more about this, guys, in the coming videos, but I thought to discuss this earlier on so that when we really get into it, you do not struggle, right? So on the left hand side, I have cold air particles, or a cold MS. And this cold air is applying, of course, we said cold air always applies high pressure on the ground. Okay, so there's high pressure on the ground here. And then on the right hand side, I have warm air. Warm air is light, it is less dense, it tends to rise up, and so it doesn't apply a lot of pressure, right? And now we have an area of high pressure and an area of low pressure. And they usually use the terms a pressure gradient is then created. We'll talk more about those. But because now we have an area of high pressure, an area of and an area of low pressure, air will always tend to move where there is not enough of it, right? There's so many particles on the left hand side. There's no space. You can imagine it is very uncomfortable if you may think of it that way. So that is your cold MS, or your cold air, very closely stacked like that. There's no space for these particles, and so they prefer to move towards an area where there is a lot of space. And as you can see, guys, we said warm air tends to rise up and expands. Okay, so it leaves a lot of space, and so these particles will definitely want to move from an area of high pressure where they are, where it is congested, towards an area of low pressure where there is less number of particles, or spaced out particles, if you may put it that way. So there is a force that exists there that pushes these guys right over here, pushes them towards those guys over there. And that force, we call it the pressure gradient force. Okay. Now you have these air particles that are cold moving towards this area that is warm. So a low pressure, guys, it is a low pressure because you have warm air that rises and expands, and so it's applying a low force on the ground, and so it creates a low pressure. Okay, I don't want you guys to say that a low pressure creates warm air. No, it's warm air that results in a low pressure because it rises up, tends to rises up and expands, and so applies little force on the ground. So it's important to note that. So we're saying that now these air particles are going to move from this area where they are congested, where they are closely stacked, where it is compact, towards the area where there's a lot of space for them to move around, right? So now this means that I am moving these air particles, moving them towards those air particles. So that means that I'm taking this cold air and moving it towards this warm air. Okay? right? And so now this area will be cooler, right? Because now it has cold air that has traveled from an area of high pressure towards it. Okay, so now it will become cooler eventually. It will be cool. And so now this means that the temperature will decrease. This means that the temperature is controlled that way. Okay, so this is important to note, very important concept there. Okay, so let's zoom in here. We're saying that the equator, because it receives a lot of insolation, it gains a lot of energy. So more energy is gained than lost. Okay, we have a positive heat balance. Okay, we have more than enough energy. And at the equator is the opposite. Actually, we do not receive enough insolation, and we reflect the little amount of insolation that we get because of the high albedo snow, right? And so here we have a negative energy balance. We need more energy because we do not have enough of it, right? And so now, because there are differences in temperature or differences in heat, what about the pressure? I have warm air at the equator. What does warm air tend to do, guys? Warm air tends to rise up and expands. And so, how much pressure does this warm air apply on the ground? It's little pressure. So, there's low pressure at the equator. Okay, we'll talk more about the pressure belts, okay, in the next coming episodes. There's an area of low pressure at the equator that is created because of the warm air. And at the poles, there's cold air, right? And so because there's cold air tends to sink down. It tends to apply a lot of force on the ground. And so on the ground here, we create an area of high pressure, right? So there's an area of high pressure at the poles, an area of low pressure at the equator, right? And then now what's going to happen? What's the next thing that's going to happen? A pressure gradient is created. And now air will move from an area of what? An area of high pressure to an area of low pressure. So the cool air from the poles will move towards the equator, okay? We'll update this as we go, guys, because there's a lot more going on here. So we'll update this, but so far please hold on to this. Okay, so now air is going to move from an area of high pressure to an area of low pressure. Now moving air, when air is moving, guys, okay, when you have moving air, as you can see for an example here, this cold air is moving, right? Moving air is what we call wind. Wind is moving air. That's it, nothing more. When you have air that is moving, that is wind. And so now this means that these are winds. Winds are moving from the polar regions to the equator, okay, from areas where it is cold to areas where it is warm. So now this means that the energy here is now going to be balanced, okay, at the equator, because it had a lot of heat, and now that heat is being lowered by introducing these cold winds from the polar regions. So these winds basically regulate the temperature there. They lower that positive heat balance, try to lower it so that it can be much more moderate. Okay, so that is regulation, guys. That is trying to balance the energy here at the equator, because now you have these cold winds that have moved from the polar regions to the equator. The equator was too hot, but now it gets cooler and cooler and cooler. So it is balancing. So there's a balance now. Okay, at the equator, it is not as hot as it would be if you had not had these cold winds moving from the polar regions. So that is an important thing to note. We're saying that the unequal heating, yes, causes an energy imbalance. And then this difference in energy results in atmospheric pressure differences. We talked about that. Okay, the difference in energy resulted in the equator having an area of low pressure because you had warm air there. It is too hot, so it rises up, leaves an area of low pressure, and an area of high pressure at the poles because you have cold air, right? And pressure differences cause the pressure gradient force, okay, the force that pushes air to move and causing wind, right? So the pressure differences, as you can see, you have high pressure there, low pressure there, they cause this force. So there's a pressure gradient force that pushes this cold air towards the equator, right? So pressure differences cause the pressure gradient force to push air from the high pressure to the low pressure, distributing cold air to warm regions, and vice versa. We'll talk about vice versa just now. Okay. So far, we're saying that cold air is distributed from the polar regions to the equatorial regions, the equator. So now the equator becomes cooler. Now, what about the poles? So we said that at the equator you have warm air, and for you to have that low pressure there forming, what happened to that warm air? So the warm air, the equator rose up. That's how you have a low pressure forming there. The equator is exposed to intense heating, right? So I'm just going to illustrate this over here. So let's say this is the sun right over here, and this is the ground right over here, right? So the sun emits its energy, okay? It releases its energy, the solar radiation, right? Or the solar energy or the sun's energy. This solar radiation is then absorbed by the ground, okay, by the surface, okay? Remember absorption? It is absorbed by the Earth's surface and then converted into heat. Okay, so from your solar radiation, the ground converts that into heat. So now the ground becomes warm, right? Or hot. And when it is hot, it transfers this heat energy, transfers it to the particles, the air particles that are close by. Okay, the air that is close to the surface receives this energy. We say this type of transfer is called conduction. Okay, conduction is a heat transfer by contact. Okay, when you have two objects, in this case, you have air and surface. The surface, the warm surface, transfers this heat, transfers it to the air particles that are close by, and we call this conduction. This is when heat is transferred between objects that are in contact, right? So now this means that these air particles or this air that is close by will receive energy, right? It will get excited, right? It will become warm. It will convert that energy into kinetic energy and get excited, okay? And this is a movement energy, so it will want to move around, right? It gets excited and it has this amount of energy, and then it's going to rise up, right? It rises up because it has a lot of energy. It is less dense, so it's going to rise up. So this all occurred because of intense heating. When you have intense heating, the sun heats up the surface heats up the air, and the air rises up. Okay, and this rising up of air, we call that convection. Okay, because it is excited, it has a lot of energy, right? And so this air is going to rise up. Okay, rises up, and so it's carrying this heat that it received from the surface, it's carrying it to upper atmosphere, to higher and higher altitudes. This is another type of heat transfer, of the vertical movement of air carrying the heat to higher altitudes. That is convection, guys. When we talk about convection, we talk about air that has received heat from the surface and now has energy and then rises up. So by rising up, it therefore leaves an area of low pressure because it is rising up, right? And so it doesn't apply a lot of pressure on the ground, so it leaves an area of low pressure on the ground. That's how we got the low pressure at the equator. It's because of this intense heating. Okay, that should have been heating. Okay, so that's what happens, guys, at the equator, right? You have warm air right over there, and the warm air received that energy from the surface, okay, via conduction. And then that warm air gets excited and then it rose up. Okay, that is convection, right? It rose up just like that. And when it rises up, what happens is that it separates at higher atmosphere, okay, or at higher altitudes, I mean. It separates, we say that it diverges, guys, okay? It separates, it diverges and moves towards the poles, okay? It is moving towards the poles and hence transferring this heat energy towards the poles. Now the poles will receive this energy, okay? They have a negative heat balance, okay? They are in need of energy because they do not have sufficient energy. It's negative energy. So, or negative heat balance. And so now they are going to receive the energy that they need. And so this will balance out the energy at the poles. Okay? So that's how we balance that energy at the poles via convection, right? And divergence at upper atmosphere. And then the energy at the equator, we balance that out by pressure gradient, where you have the cold air at the poles moving towards the equator, because the pressure gradient is created. Like you have, by that I mean you have when you have areas with different pressures. Okay, the pressure gradient is created, meaning which air will move from the high pressure towards the low pressure, and that's how we moved that cold air from the poles towards the equator, where you had more than enough energy. So now you want to reduce that energy so that you have at least enough of that. So that's just balancing things out. So you have warm air moving from warmer regions to colder regions, and cold air moving from colder regions to warmer regions. Okay, that's how the energy balance occurs, guys, by winds. Okay, that's how winds transfer energy, ensuring that it is not too hot or not too cold in the different parts of the earth. Right, so that's number one, the role of winds in balancing energy on earth. And then number two, we have ocean currents. Ocean currents also balance energy on earth. Okay, let's take a closer look at ocean currents. First of all, what are ocean currents? Now, simply put, guys, okay, simply put, a current, or an ocean current to be specific, it is seawater moving within seawater. I don't know if you guys have ever noticed this, because yeah, it's quite hard to notice. So let's say you have a glass kettle. Okay, let's say this is glass. You can see through, right? A transparent, let me just say a transparent kettle. So you place water in there, and then you switch on the kettle. And what happens over time, guys, is that particularly when it's about to boil, when the water is getting warm, right? What happens, you're going to see these bodies, if I may call it that, bodies of water shooting up, okay? Just shooting up like that, shooting up like that, shooting up. Okay, so this is water, but it is moving in water, right? Because this is a whole body of water, all of it. But then you now have this sort of train, or this fluid, this body of water moving within this water. That is what we call a current, guys. Okay, that is what we call a current. You have, okay, so let's say this is the ocean. Okay, within the ocean, you have bodies of water that are moving there, transferring heat from other regions to other regions. Now, these bodies of water, or these directed movements of water, are moved by multiple factors. It could be wind, okay? Should have said factors there. Could be wind that forces them to move, or Coriolis force. We'll talk about Coriolis force, or temperature, or differences in density, or differences in salinity. So there's a lot that contributes to having currents existing, okay, or having currents moving within a body of water. Okay, so you can sort of think of these as trains or bodies of water that are moving within the ocean. Okay, so these bodies of water, or these currents, what they do is that they transfer heat or energy from the equator or from the poles. Okay, they transfer heat from the equator to the poles, and from the poles to the equator. Okay, transferring heat as moving bodies of water within the oceans. Different currents, many different currents exist, guys. And for this episode, we will only mention two important currents, particularly the ones that surround South Africa. And these ones, you really have to know them. they are very important. Okay, so South Africa has two major ocean currents around it. So this is the country, South Africa, right? And South Africa has two major oceans. Okay, just Africa as a whole actually has two major oceans, right, around it. So on the east, what do we have, guys? Which ocean do we have on the east? The east is the right hand side. So on the east, we have what? We have the Indian Ocean. And then on the west, what do we have on the west? We have the Atlantic Ocean. So always, guys, on the east we have the Indian Ocean, on the west we have the Atlantic Ocean. Important to note. And on these oceans we have these ocean currents. Okay, you have ocean, right? But you have bodies of water moving within these oceans. So the first one is the Argulas current or Argulas current. Okay, I don't know, the pronunciation is not very important. So the Argulas current moves on the eastern side of the country, right? Meaning which it moves along, or it is found in the Indian Ocean. Okay, it is a warm current. Okay, that is found in the Indian Ocean, and it moves southwest. So it moves from lower latitudes, okay, from your equator, or from your tropical regions, and it moves towards the higher regions. Okay, so that means that it transfers heat, okay, from, or it takes energy or heat from the tropics towards the higher latitudes, okay, the cooler latitudes. This is important to know. This is the Argulas current. Okay, the Argulas current. It's found on the eastern side, guys. It is warm. It brings warm water, which also affects the air. The air also becomes warm. It brings warm and wet conditions on the eastern side of the country. Okay, warm and wet conditions on the eastern side of the country. Okay, reason why you have a lot of rainfall on this side, part of it is because you have this Argulas current, this warm Argulas current on the eastern side. Okay, and then on the western side you have the Benguela current. It's on the west in the Atlantic Ocean. It's found in the Atlantic Ocean, and it is cold. It is a cold current, and it moves northwest, or it moves northwards. Okay, it moves this way. Okay, it moves that way. So this is the Benguela current. The Benguela current, it moves towards your tropical regions. It's going to move towards Angola. It will bring cold conditions there. Okay, it is warmer that side. It is warmer at the tropics, in the lower latitudes. So it travels from the higher latitudes to lower latitudes. Whereas the Argulas travels from lower latitudes to higher latitudes. Okay, so this transfers cold air, or brings cold conditions towards lower latitudes from higher latitudes. Okay, and so that means that it regulates the temperatures of the lower latitudes. And on the western side, the effect that it has on the western side, it makes the western side cold. It brings cold and dry conditions on the western side. Okay, that's why we have a desert on the western side. Okay, because you have a Benguela current there. It is very arid. You have an arid climate, a semi-arid climate on the western side, and the Benguela current has actually a major effect on that. It brings in also the cold and dry air. Okay, these bring air. They influence air that they bring towards the side of the continent. So, for example, the Argulas current brings in warm and moist air, or warm and wet air into the eastern side, and this promotes rainfall. And so that's what we mean by wet conditions or wet climate. This warm, moist air rises up, cools down, and condenses, and it rains on the eastern side. Then on the western side, you have cold and dry air. Cold and dry air does not promote any rainfall. Okay, and so that's why it is dry here. That's why we have that climate on the western side that is dry without any precipitation or rainfall occurring there much. Okay. So that is important to note there. So this means that ocean currents also balance the energy. Okay, call these surface ocean currents. They balance the energy there. They take in energy from the warm equatorial regions or tropics, distribute that energy to higher latitudes where you have little amount of energy, where energy is needed, okay, towards the polar regions. And then the negative energy from the polar regions is then taken by the cold ocean currents towards the lower latitudes, okay, where there's excess amount of energy, when you need to reduce that amount of energy. So this means that the energy is going to be balanced there, guys, because cold conditions from the higher latitudes are taken to warm low latitudes, and the warm conditions from the lower latitudes are taken to the higher latitudes, which are relatively colder than the lower latitudes. So now energy is distributed that way, it is balanced in that manner. Okay, so that's what you have to understand in this video, guys, the role of the winds as well as the ocean currents in ensuring that energy is balanced, okay, in ensuring that you take that cold air to the warm regions and take that warm air to the colder regions, therefore balancing the amount of energy there. I hope this was helpful. Thank you again for tuning in, and please like, subscribe, share, and comment, guys. Let's grow this channel further. We can even include more subjects, guys, if we happen to grow this channel even further. Okay. Thank you again, and I'm looking forward to the next episode.